Hello Year 11 and welcome to our 7th exercise here for our 10th topic of measurement. We're looking at land surveying here. We're not asking questions here, not that kind of a survey. We are measuring the Earth's surface the way that a professional surveyor might, using their equipment. Now, having said that, we talk about professionals and equipment, whatever else, and I'm going to talk to you here about measuring the dimensions of an irregular parcel of land using a method called an offset survey. There are, in practice, great inefficiencies and inaccuracies with measuring things this way, but it does get us started with the idea of some practical method of measuring the ground. So what we do is we lay out, think of it as laying out a tape measure along a diagonal, right, between two corners of our irregular field, and generally along the longest diagonal. Now, at various points along this diagonal, right, at right angles to our diagonal, we will be able to measure an offset to another feature, let's say to another corner. Right, so you can see in this diagram here, my diagonal is the line FL. So the idea is that I walk along that diagonal until I am exactly 90 degrees, right? Until something is directly over my left or right shoulder. And then, observing how far along the diagonal I am, I measure at 90 degrees to my diagonal off to those corners and record those like this. An advantage of this method is that it fairly neatly dissects our area into a series of triangles and trapezia, and they're quite easy to calculate areas and lengths, right, using those things. So there's lots of right angles involved. That's good for calculations, tends not to be great for measurements. So here we go. This is what we call a field diagram. There's a thing called a notebook entry that we'll get to here in this example. I'll show you how that works. Now, part A asks us to calculate the area of this parcel of land. So, what we're going to do is to look at this shape here, and we are going to dissect it into a couple of different shapes and calculate the area of those individual shapes and add them up. Now, first of all, I'm going to look at this little area up in here. Now I can see, so we're going to call it triangle FAI. I'm going to call it area of triangle FAI is equal to half the base times the height. Half times 5 times 23. Oh, jeez, I'm not thrilled by the prospect of doing that. Not clear. Half 0.5 times 5 times 23 equals 57.5 square meters for that little one. Okay, so this here, 57.5. I'll put a little tick there because we've done this one. Now this here, this is a trapezium. Be careful, it's not a rectangle. Okay, I can see it's 25 plus 14. So that there is 39 along that side. This one is 25 and this one is 23. Now they're both at right angles from our, what we call our traverse, this long diagonal, our main diagonal there, our traverse line. These are parallel. They're both at right angles to the traverse line. So these are parallel, which is what creates our trapezium. So remember that this time I'm going to say the area of, let's call it AIEC, is equal to the average of our parallel sides. That's 23 plus 25 over 2 times the distance between them, which we said was the 25 plus the 14 is 39. Okay, now the average of 23 and 25 is 24. 24 times 39, thank you again calculator, 24 times 39, oops, okay, 936. Pretty slow process working out these areas. Okay, there's another one done. Oh, that's a big tick. This little triangle here, well, this is nice and easy. 30, 25. So this time the area of LCE, oops, that little triangle there, LCE, is half times the base times the height times 30 times 25 equals 15 25s, anyone? Not in the mood. 15 times 25 equals 375. That's this one done. Now, we could say we've got two triangles here left, or we could think of it as one big triangle. The perpendicular height is going to be 40. How long is the base? 5 plus 25 is 30. 44, 74. So, my last area here, the area of triangle LAD is half times, I forgot the number, that was it 74? What have I got? 44, 69, 74. Half times 74 times 40 equals, calculate again, 0.5 times 74 times, oops, 40 equals 1480. Okay, that's good, and that's that area done as well. Now my area total, I'm just using these subscripts just so I can see what I'm doing there, is the sum of these things. Is the 57.5 plus 936 plus, I shouldn't write these down the page, but I've run out of space, 375 plus 1480. So my total area is the sum of all of those things. Okay, so the area of that parcel of land is 2,848.5 square metres, which is a bit more than a quarter of, no, sorry, 1 hectare, remember, is 10,000 square metres. Yeah, so it's a bit over a quarter of a hectare, a little over a quarter of a hectare there. So, we've calculated the area. We need a notebook entry. The way we do this, I'm going to sort of zoom in because I need a bit more space, but I also need to be able to see the diagram as I do this. Our notebook entry, right, looks a little bit like a double-sided stem and leaf plot, I suppose, in some respects. So I'm going to put F at the top here, and then underneath that, you can see I start with a 0 and then a 5. And off to the right of the 5, I've got 23, and that's to point I. Space. Yeah, I can do it over here, hopefully. Now, below that one, okay, now I've got another 25, so we add them together to make a 30 here. Okay, so from F come down 30, right, that gets us to where B is, and then on the left hand side, right, there's something, if I go 40 meters over to the left, I'll get to a point called D. So from F go 0, there's nothing there. From F go 5 meters and then 23 meters to the right, gets you to point I. From F come down 30 meters, then 40 meters on the left gets you to D. From F come down, so we've just done 30 and then another 14, so 44. And right, I need to go to the right 25 meters and that's to point E. And then we go another 30 meters, so that brings us to the 74 altogether, gets us to the point that is called L. Now we might very well just draw some lines here, right, a bit like our double-sided stem and leaf plot, just so we don't confuse our digits together. And that's what we call a notebook entry, right? That this little sort of list of numbers here, right, provides the same information as that diagram. Rightio. So that is, right, that's the first part here for land surveying using an offset survey. Then we have this idea called the trapezoidal rule. This is getting away from us now. The trapezoidal rule we use for calculating irregular areas where I have some measurements. So we recognize that this is an irregular area, right? No matter how many measurements I make of it, it's always going to be quite hard to calculate the area. So you can see here, I've got this weird looking shape here. I need to make parallel measurements sort of across that, and ideally at the ends. You can see my measurements here aren't exactly on the end, okay, but there's always a certain amount of guessing with this, right, or of a certain amount of judgment. If I put them right on the ends, then it gets very narrow, my measurements, right? It makes it look like I have a very, very skinny trapezium. It's a bit of a balancing act. You typically won't have to make the decision about where those measurements are made. Usually you'll be given a diagram that already shows you measurements have been made. Nonetheless, for one application of the trapezoidal rule, I need two measurements that are parallel to each other, and I need to know how far apart they are. And then using the area of a trapezium, right, the average of my parallel sides, multiplied by the distance between them, that will give us an approximate calculation of the area. Right, and you can see there's that formula there. I add the parallel sides together, divide by 2, right, that's my average, and multiply by the distance between them, which we abbreviate to h. H for the distance between, df is my first distance, distance first, dl, distance last. Now, I will improve the accuracy of this estimate by making more measurements and using the trapezoidal rule over and over again. And all that's happening here, if you look closely, right, I've just got a trapezium here on the left and another on the right. We can kind of condense these formulas together, but we could also just look at this trapezium on the left, the average of df and dm, dm meaning the middle distance. Add those two distances together, divide by 2, multiply by the distance between them, which is h. And then do this, dm plus dl over 2 multiplied by h. Okay, and that's 2 applications of the trapezoidal rule. The more I do that, right, the more applications, the more detailed it becomes, the more accurate that estimate of the area becomes. But again, typically, you won't have to be making the decisions, about how often we do that. You'll be given a question like this example 12. So it says find an approximate area of the pond using one application. This means I'm going to ignore the measurement in the middle. Right, for part A, I'm going to say that df equals 4, dl equals 8, and h is the distance in between them is going to be 20 meters. Righto. So for part A, my area is approximately equal to, so we can use our formula. It says h over 2, so it's 20 over 2 outside of 4 plus 8. 4 plus 8 is 12, 20 over 2 is 10, 10 times 12 is 120 square meters. So that's for A. But for B, 2 applications of the trapezoidal rule, I'm going to say that my area is approximately equal to, right, I'm going to do the left and the right trapezia. So h this time drops down to 10. That's how far apart our measurements are. So it's 10 over 2 outside of, what is it, 4 plus, I need to have a closer look at my diagram. 4 plus 12. Now, I do another one of those. 10 over 2. This time it's 12 is on the left and 8 is on the right. So I do those calculations. 4 plus 12 is 16. 10 over 2 is 5. So I think 5 16s are 80. Plus, that's 20 times 5 is 100. Is approximately equal to 180 square meters. And you can see that's quite significantly different to our first estimate. So 2 applications here has significantly changed it. Looking at that diagram there, I think if you were to draw straight lines there, assuming it's kind of vaguely to scale, you would see that if I drew the original trapezium with straight sides, I will have chopped a lot of the pond off. If I draw the straight sides of the trapezium using 2 applications, I chop a lot less of the pond off and ignore it. Okay, so a couple of things in this exercise, and the video is getting away from us now, but we looked at offset surveys and calculating the area using a combination of triangles and trapezia. We looked at a notebook entry, which looks a little bit like a double-sided stem and leaf plot, kind of, sort of, although in practice that's not exactly how it works. And then we looked at the trapezoidal rule using 1 and 2 applications. That is a lot to take in. If anything doesn't make sense, if you've got any questions, jot them down so that you remember them and you can ask me in class. I'll see you then.